The fundamental theorem of algebra is a fundamental theorem of mathematics. There are several of these fundamental theorems which are so important to mathematics, they're called fundamental theorems. And this one for algebra states that if a polynomial of degree n has degree n, then it has exactly n roots. Some of those roots might be repeated, and these roots are within the complex numbers. So some of them might be complex, some of them might be real. Essentially what that means is if we have this polynomial of order n, it means we can rewrite it in factorized form as x minus something, x minus something else, and we can do n of these brackets. There will be n brackets that we can make where we have x minus some number, but the important thing here is that omega, all of these omegas belong to the complex numbers. They're not necessarily real numbers, they're complex numbers. That means that every quadratic has two roots, but they might be complex. Every cubic has three roots, but some of them might be complex. They could also be repeated. We could have something like x minus 1 cubed. That's x minus 1 times x minus 1 times x minus 1. So we can have them repeated and we can have them complex. A follow-up to this is what's called the conjugate root theorem. Now this is really, really important as well for solving polynomial equations. And the conjugate root theorem states that for any polynomial with real coefficients, if a plus bi is a root, then a minus bi is also a root of that polynomial. What that means is that complex roots come in pairs. So there always has to be an even number of complex roots, because if you have 3 plus 2i, you also have to have 3 minus 2i as a root. Now this is helpful because if we find one complex root, we immediately know a second complex root. It also means some other important things, like for example a cubic. Because a cubic has three roots, we know from the fundamental theorem of algebra a cubic has to have three roots, but complex ones must come in pairs. At most, two of them can be complex, so there has to be a real root for cubics. And if we think back to when we were looking at the graphs a moment ago, that's why a cubic always crosses the x-axis, because there's always a real root. And that's true for any odd polynomial, but not necessarily for even polynomials, because even polynomials, all of the roots could be complex, they could all pair up. So we have these two really important results here, the fundamental theorem of algebra and the conjugate root theorem. You are not given either of these in the formula booklet. You need to know them, but you don't necessarily need to use the names of them when you're using these results. You can use the results without having to name them, but it's always helpful to know the name of something because it enables us to remember it a little bit better.